Today we're going to be doing a test just to give you an indication of the speed difference between using the internet to access WAN traffic or applications in the US from distances of 300 milliseconds. We're using South Africa as the edge site, and the gateway site sits in the US in this case. So just to check where we are on a network level, our IP address is 105.209, so we're sitting in South Africa on a 50 meg MTN broadband internet link. And what we're going to start with is just a simple speed test, just to give us an indication of what speeds we can get between South Africa and the USA, in this case over 300 milliseconds. And then what we'll do is we'll use that as a benchmark for further tests once we start using the SD-WAN VPN tunnel from Accelerate, which also lands in a similar area. So on the downlink speed side, we're going to get roughly, that's pretty good, 16 megabits per second. And on the uplink speed side, we should probably get something around the range of 10 megabits per second. Right, so 9 megabits per second. Okay, we'll use that as a benchmark. And what we'll also do, because of course speed tests vary quite radically, the best example, especially when users are trying to access content, download files, movies, OneDrive, SharePoint, is to probably do a file download test. So we'll use Dallas as an example for that. We'll open that up and we'll let that run for a few minutes just to see where it settles. And then we'll measure the time it takes to download a 1 gigabit file over the internet effectively. So right now it's sitting at about 55 minutes, and of course what affects the file download speeds on the one side is distance, because the more latency you introduce between the user and the content, the slower the network becomes. And the second is packet loss, which has an equal effect on your TCP window size, which reduces the more and more packet loss that's introduced. And on the internet you find both latency and some level of packet loss, which of course varies quite a lot, and that's what creates the erratic responses that you get on internet downloads. So sometimes they're very fast, sometimes they're very slow. And as you can see now, the window size is increasing, and then you'll probably see it over some time it'll start decreasing, and it'll carry on with that type of performance. So what we'll do is we'll just take a rate now and say 600 kilobits per second will be the average, kilobytes, sorry, and roughly 30 minutes to download that video. So it's gone higher, it's gone lower. Well, let's make it 20 minutes then. Okay, on average 20 minutes. That's not too bad. So what we're going to do now is we're going to change the network, and we're going to do that because what we want to do is we want to pass that same request over the same internet, but in between the internet and the request is now our Aritari Accelerate device, and we're going to build a tunnel from that device through to the US to our gateway in the US. We have gateways all around the world, and between those two points we're going to send specific application requests, in this case the applications that we were accessing now. And in that VPN tunnel we do things like forward error correction and TCP acceleration, which improve the way the internet performs. So we're not increasing the speed of the application, we're actually increasing the responsiveness of the internet in our global public gateways. So just to do that, we're going to quickly change the network, and so that it points at the Aritari Gateway, Accelerate Gateway. We're going to press OK. We're going to apply that, and just to verify that we've done that, we're going to see what our IP address is, which should be now in the US. There we go, US. And basically what we can do is we can start a speed test, and let's see what happens. So you'll see that should change IP addresses. I may have to restart this altogether. Let me just actually restart that. There we go. So I've got a new IP address now, which is Joe's data center in the USA. Oh, and now it's connecting to Jenny Internet in Midrand. Now I'm not sure why that's happening, but that's really not what we want to do. So let's just stop that and rather see if we can choose a server. So this should pop us out into the US. Okay, so there we go. And let's do that test. Hopefully that'll give us the results we're looking for. So effectively, the thing that's going to limit this test is the size of the link, because our software allows you to use almost a whole link size. So if you had a 100 meg link, arguably you'd be able to get almost 100 megs. So now we should see up to 50 megs of download speed, which in this case looks like it's peaking out at around 41 megs. So that is a 300 to 400% difference between that and what we did over the internet, which is quite good. Again, it's an indication. The file transfers are a better indication because that's a real world example. And the uplink speed in this case is around 400-500% increase at about 35-36 megabits per second. Okay, so we'll leave that. Let's go back to the important stuff. The important stuff is in fact what happens when you download a file. And let's have a look. So we had a 20-minute average and a speed of around 600 kilobytes per second. So we've now got 4.6 megabytes per second, and there's not much more you can get out of that link, because 5 times 8, I mean, you're getting to almost a full link speed, 40 to 50 megabits per second, and this download is going to happen in 3 to 4 minutes. Now, if this was a 100 meg link using the same software and the same accelerate gateways, you would do that in roughly half the time, because your window size would be roughly 8 to 9 megabytes per second. Whereas if you're using the internet and you have a 100 meg link, you're not going to get much more than 16 megabits per second, because the limitation is latency, not the amount of bandwidth that you have in the network. So that as you can see, is considerably faster. In this case, it's up to 10 times faster. In the case of bigger size links, 20, 30, 40, 50 times faster, depending on the link size that you have. So now, I mean, we're now sitting in the US, so practically speaking, we can look at what it means to actually stream movies. So as you can see here, that download has actually occurred. Let's just skip that ad and let's just see what the window looks like. So there's the download bar of the movie from the US. No buffering, no timeouts, because it's able to get the content down, even at an HD or UHD level, faster than it would for the bar to catch up to it. And that's pretty impressive. And this is relevant if you're doing things like HD or UHD video streaming or video conferencing around the world, where you want consistent performance of that video conferencing, which you typically won't get over the internet alone. So that basically gives you some idea of the difference in speeds that you get from the Accelerate solution. And this is basically an SD-WAN product. So this effectively could be your head office site, and you'll be accessing accelerated applications globally or domestically. This obviously can extend into your DC. Multiple branches, hundreds of branches, in some cases thousands, can be used and supported by these types of technologies.